Welcome back to All This Math. This is Professor Parker. Make sure you're subscribed to the All This Math YouTube channel. Go ahead, like the video, drop a comment down below in the comment section. Also, share this video with some other people. All right. Now, what we're doing today is we're doing an example of the type of question that a child might see if they're in the 8th grade and they're taking the HSPT math exam or the math portion of the exam. HSPT stands for High School Placement Test. It's a test that 8th graders in Catholic or parochial schools take. All right. Now, let's read the question. It's a short word problem. Short word problem, only one sentence, right? But we still approach it the same way we would approach a longer word problem. That was several sentences. This says, how long does a 420-mile trip take moving at 65 miles per hour? Now, these problems are what I personally call these dirt problems. Dirt problems. And why do I call them dirt problems? Because these problems require the use of, or maybe not require sounds mandatory. These problems can be completed, I should say, can be completed using the distance, rate, time formula, or the distance is rate times time formula. That's why I call it dirt, right? Because here go the formula. D equals RT, right? And if we understand math language, translating math language into the English language, the equal sign is equivalent to the word is. DIRT. Distance is rate times time. Dirt. I call these dirt problems. All right. Now, what are we looking for? It says, how long does the trip take? How long does the trip take? That means we're looking for the time. We're looking for the amount of time, right? Do we know the distance? Yes, we do. It's a 420-mile trip. So we know the distance. Do we know the rate of speed? R stands for rate. Rate of what? Rate of speed, or how fast the car is going on average, right? 65 miles per hour. So we know R and we know T. We don't know D. So this is a pretty straightforward problem, right? Actually, no, I shouldn't have checked this off. We know D. We don't know T. I don't know why I checked T. We don't know T. So let's just like replace the variables that we know, the values that we know with the variables, right? So I know what D is. D stands for distance. Distance is 420. So we're going to say 420 is equal to, now the rate of speed is 65 miles per hour. So I'm going to replace R with 65. Now I do not know what the time is, so I keep that. All right. Now I'm trying to solve for T. So we're doing algebra. We're solving a linear equation. We need to isolate T on the right side of the equation. That means we need to eliminate this 65. Get rid of this 65. How do we get rid of this 65? We get rid of the 65 by doing the opposite operation from what the 65 is involved in. The 65 is involved in multiplication. So we need to do the opposite of multiplication, which we need to know is division. The opposite of multiplication is division. So that means we need to divide by 65. And we also need to remain balanced. So in order to keep the equation balanced, if I divide by 65 on the right-hand side, I need to also divide by 65 on the left-hand side. Now, 65 divided by 65 is 1. So that leaves me with one T, right? 1T. Now, we need to understand the language of mathematics, understand the language of algebra. 1T is equivalent to just saying T. We don't need to say 1T. We don't need a coefficient 1 in front of our variable. We can just say T. So that's T. Now, we do need to know 420 divided by 65. Now, 420 divided by 65. Now, it just so happens that under normal circumstances, we would take out our calculator, do 420, hit the division button, do 65, hit the equal sign, we'd have our answer, we'd be done. However, the HSPT does not allow the use of calculators, so we must use either mental math strategies or handwritten math to find out the quotient of 420 divided by 65. Now, how would I do this? Now, what I would do is this. I would say I might do like a partial quotients method to do this. I might say, all right, 420 divided by 65. I might think of, okay, what are multiples of 65 that are less than 420? Or is 420 a multiple of 65? Let's see. Let's do 65 times 6. 65 times 6 is going to be 390. 65 times 6 is going to be 390 because 60 times 6 is 360. 5 times 6 is 30. 360 plus 30 equals 390. So that means if I do 60, that's probably the closest I can get to 420 without surpassing it. 65 times 7 would be greater than 420. That'd be 455. All right. So that means that, let's say I break this down into 390 and 30, right? 390 divided by 65 is 6. 390 divided by, so this is called the partial quotients method. If you learn this in school, it's probably not going to be written like this. It'll be written differently, but it's still the same concept. Break 420 into 390 and 30. Now, why? Why did I break it into 390 and 30? Because 390 is a multiple of 65. 390 is a multiple of 65, meaning I can multiply 65 by 6 and it will equal 390 with no remainder. That means 390 is a multiple of 65. Now, how did I know that? I just experimented. I just said, well, what's 65 times 6? I didn't already know that before I started this problem. And I tried it. I see what happened. I said, oh, I end up with a number that's close to 420. And I also know that if I multiply by 7, that's going to put me over 420. And that's not what I want, because I'm trying to see how many 65s can fit into 420. That's what 420 divided by 65 means. That's what the concept of division means. How many of the divisor can fit into the dividend? How many of the denominator can fit into the numerator? How many of the divisor can fit into the dividend, right? How many 65s can fit into 420, right? 6 can fit in because 6 goes into 390 evenly with no remainder. But what's left over? 30. So then we got to do 30 divided by 65. 30 divided by 65. Now 30 divided by 65 is around like a half. It's a little less than a half. It's a little less than a half, right? But let me, you know what I'm gonna do? I'm gonna do some quick long division, right? Because I want to do 30 divided by 65. So 65 is my divisor, 30 is my dividend, and then 65, 30 is too small. So I need to put a decimal point right here and then attach a 0. Now I'm doing 65 into 300. How many 65s can fit into 300? All right. That's going to be, I know 6 would be 390, so that's too many. 5 is still too many because 5 is over 300. It's going to be 4, right? 65, because 65 times 4 is going to be 260. 260. Because 60 times 4 is 240. 5 times 4 is 20. Put the 240 with the 20, you get 260. So then you write 260 right here, right? And then we're going to put our subtraction sign, because in long division, we do DMS, divide, multiply, subtract. So we divided to get the 4. We multiplied to get the 260. Now we're about to subtract. 300 minus 260 is going to be 40, right? So now 65 is too large to fit into 40. So we're going to attach another 0 just to bring it down. Now we got 400. All right. Now I already know that 65 times 6 is 390. So therefore 65 must fit into that many 65. 6 65s can fit into 400 also, because 390 is very close to 400. 390 is very close to 400. So I'm going to put a 6 right here, right? Then I'm going to do my multiplication. 65 times 6. We already know it's 390. So you write your 390 right there. Draw your bar, minus sign. We got 10. Now, this is 2 decimal places. This should be good. This should be good. So what I know is this. I know that 390 divided by 65 is 6. I know that 30 divided by 65 is 0.46. Again, partial quotients. I broke the 420 down into 390 and 30. 390 and what was left over? 30. Because 390 plus 30 is 420. 390 divided by 65 is 6. Then the leftover 30, you do the 30 divided by 65. That's going to be a fraction, because 65 is bigger than 30. So it's no way that a whole amount of 65, a whole number of 65s can fit into 30, because 30 is too small. 30 is less than 65. That's why only a decimal or a fractional amount of 65 can fit into 30. That's why we have a decimal, 0.46. So our answer, you put these two numbers together, 6.46, right? So you go over here and you got 6.46. Now, they ask how long does the trip take? It would be 6.46 hours. However, this particular question that I found online, it was a multiple choice question, and the answers were in terms of hours and minutes. Hours and minutes, not just a decimal like this, not just in terms of hours. So that means we have to convert 0.46 into a number of minutes. We have to figure out how many minutes is 0.46. Now, common mistake students always make in this type of problem if they don't know how to do it. A lot of students don't know how to do this conversion. They automatically assume that, oh, 0.46, that must mean 46 minutes. No, it does not. 0.46 is a fraction of an hour. 46 minutes is also a fraction of an hour. It's 46 out of 60 minutes. 46 out of 60 is a little more than 3/4. 0.46 is not 3/4. 0.46 is less than 0.5, which means it's less than a half. This is less than a half an hour because 0.5 is a half, which means 0.5 hours is a half an hour. So our answer should be, the number of minutes should be somewhere close to a half an hour or close to 30 minutes. But this is how we tell exactly how many minutes it is. We take this 0.46 and we multiply by 60. Why do we multiply by 60? Because there are 60 minutes in an hour. And that's going to give us the fraction of an hour that we had. So 0.46 times 60. So what we're going to do is this. I'm going to do it the old-fashioned way. Multiplication algorithm. Standard multiplication algorithm. 0.46 times 60. Let's go. 0 times 6 is 0. 0 times 4 is 0. Then we go to the 6 over here. 6 times 6 is 36. Don't forget to indent. Put the 6 down. Carry the 3. 6 times 4 is 24. 24 plus 3 is 27. Draw your bar. Put your plus sign. And do your addition. 0 plus nothing is 0. 0 plus 6 is 6. Nothing plus 7 is 7. Nothing plus 2 is 2. Now, where does the decimal point go? So when we're multiplying decimals, we have to look and see, okay, where does the decimal point go in our product, right? Because we have 0.46 times 60. Now we go back to the original factors in the multiplication problem, and we ask ourselves, how many digits were to the right of the decimal point out of these two factors? 1, 2. After the decimal point, we got a 4 and a 6. That's 2 digits. After the 60, we have no numbers, no digits after the decimal point. So therefore, if in our original factors, there were a total of 2 digits after the decimal point, in our product, we should have 2 digits after the decimal point, which means the decimal point should go between the 7 and the 6, because now we got a 6 and a 0 after the decimal point, right? 27.6. So that's how many minutes? 27.6 minutes. And we can round that. We got to know how to round. This 6 makes the 7 go get rounded up to an 8, which is going to be 28 minutes. So that means our final answer, right, based on the answer choices that were given when I found this question online, 6 hours and 28 minutes. 6 hours and 28 minutes. That's what we got, 6 hours and 28 minutes. All right, 6.46. We solved for T. We got 6.46. We did 420 divided by 65. There are a lot of ways to do the division. 420 divided by 65. I did like a hybrid partial quotients method / long division method. I did 65 times 6. How did I know that was going to work? I didn't. I just guessed. If it hadn't worked, I would have multiplied 65 by another number to get closer to 420. But it just so happens 6 worked. It got me to 390. 390 is as close as you can get, right? For a whole amount of 65s that could fit into 420. What was left over? 30. So then I want to know how many 65s can fit into 30. I know it's going to be a decimal because 65 is more than 30. So how can 65 fit into 30, right? I know it's going to be a decimal. Only a fraction of 65 can fit into 30. That's why our answer was a decimal. And we already knew that. We knew that was going to happen, right? I use long division to do this. So long division is another good skill that we should have. All right. 65 goes into 300. Into 30, 0.46 times. So about half of 65 can fit into 30, which should make sense because 30 is half of 60, is exactly half of 60. Then we take that. Okay, boom, we got 6.46 hours, but we need to know how many minutes 0.46 represents. 0.46 represents 28 minutes. 0.46 represents 28 minutes. All right. And how do we get that? We get that because we do 0.46 times 60. 0.46 of 60 minutes. See, math language. The word of means multiply. So it's 0.46 of 60. That's what we're working with. All right. So that's about that. Make sure you are subscribed to the channel. Make sure you like the video. Make sure you share this video with somebody. All right. And if you have any questions about anything we did, please do not hesitate. drop your question in the comments. Drop your question in the comments. Or if you just got a comment about something else, or if you want to see some other videos about some other content, let me know in the comments. Put it in the comments. All right. See y'all later.